Our next question is from GATE 2015, mass transfer for 2 marks. A binary feed consisting of 25 mole percent liquid, 75 mole percent vapor is separated in a stage distillation column. The mole fraction of the more volatile component in the distillate product 0.95. The molar flow rate of distillate is 50% of the feed flow rate, and the McCabe-Thiele method can be used to analyze the column. The Q line intersects the operating line of the enriching section at 0.35, 0.5 on the XY diagram. The slope of the stripping section operating line up to 1 decimal place is. Let's start with the solution. This is the McCabe-Thiele diagram. They have given XD is 0.95, that is 95%, and they have given one more thing. The Q line intersects the operating line of the enriching section at 0.35, 0.5. Right, suppose there is a Q line will be there, so you know that whenever we draw the McCabe-Thiele diagram, our stripping section line also pass through this intersection point, right? We know these 2 points for enriching section line. If we know that we can calculate from here the reflux ratio. Operating line equation will be given as, in case of enriching section, will be given as R upon R plus 1 xn plus xt upon R plus 1, where R upon R plus 1 is the slope and xt upon R plus 1 is the intercept. You can see here intercept is xt upon R plus 1 and slope of this R upon R plus 1. If we know that R upon R plus 1 should be equal to, we have given 2 points 0.95, 0.95, and we have 0.35, 0.5. From this we get y2 minus y1 upon x2 minus x1, right? From this we get the slope of this line, that is 0.75. After solving I got R is equal to 3. Now this is the condition actually they have given. You can see here I have made this distillation column, right? Vapor is coming into condenser and condense, and there is a, they have given let's suppose we take feed is 100 mole per hour, right? Then they have also given that distillate flow rate is 50% of F, that is 50% of F, that is 50 mole per hour, right? And there is also some reflux is there and it will go downward, and also they have given feed is 25% liquid and 75% vapor, so that means 25% of the amount will go downward and 75% of the vapor will go upward, right? And this is the reboiler, that Vm is the vapor is generated from here and this is going upward direction. So if you understand this, then you can solve this problem within a 1 minute or 2 minutes, right? Now we will see here D will be 50 mole per hour, and you know that reflux ratio is given as L by D is equal to 3. What is L by D? D is there and L is here. This is the L, right? This is the L actually, right? L. So from this I know the flow rate of D. From this we get L is equal to 150 mole per hour. No problem. Now I am mentioning Lm below the feed line plate. I am mentioning it as Lm and Vm, liquid flow rate and vapor flow rate, denoting with Lm and Vm. In enriching section I am denoting it as V and L. Remember this. Now what will be the Lm? Lm will be this much L plus how much is coming from the feed is liquid. So this is the total liquid flow rate in the stripping section, right? L plus this. So you can see here we have 25% liquid, so you can see here Lm will be 150 mole per hour, that is coming from the reflux, plus 100 mole per hour into 0.25, that 25% is liquid from the feed. So total liquid flow rate in stripping section will be 175 mole per hour. Now we will see the vapor flow rate. You can see here vapor flow rate in the enriching section will be V is equal to L plus D, if you apply the mass balance around this condenser, you will see V is equal to L plus T. Right, I know the L, that is 150 mole per hour. I have calculated it earlier. So vapor flow rate is 200 mole per hour. So I just need to calculate the V from the bottom, vapor flow rate in the stripping section. So how much, you can see here, this much amount is going in upward direction, and also 75% vapor is coming from the feed. So this total will be equal to 200 mole per hour. That is, we have calculated is as 200 mole per hour, right? So Vm will be 200 mole per hour minus 100. So I will subtract this much amount. So we from this we will get Vm, right? So Vm is equal to 200 mole per hour minus 100 mole per hour into 75%, that is 125 mole per hour. Slope of stripping section line will be given as Lm by Vm. Remember this, Lm by Vm. So I have calculated Lm, I have calculated Vm. From this I got 1.4. This is the final answer, right? So thank you. Please make sure to like, share and subscribe my channel. Thank you.